Okay, so what are we gonna do today? Well, since we only have about 30 minutes of class, I'm going to continue on with solving exponential equations. And what we get through today, we get through today, and what that'll be on the test, and what we don't get through today, obviously won't be on the test. So, last time we were solving things with base E and base 10, right? And with that, we can use our calculator. Well, we can also solve exponential equations with other bases as well. So, okay, that's okay. So for instance, if we're going to solve, let's do 5 times 1.07 to the x power is equal to 350. So our standard procedure is I want to isolate the exponential piece. In this case, that means I would divide by 5 on both sides. Now, if I take 350 divided by 5, I'll get 70. So I end up with 1.07 to the x power is equal to 7. Now there's a couple of ways we can look at this, solving this part from here on down. Previously, when I had something like e to the x power equal to 70, I just said, let's apply natural log to both sides. And the left-hand side just becomes an x, and the right-hand side becomes whatever natural log of 70 comes out to, right? Well, there's 2 options at this stage, okay? Option 1 is apply log of this base to both sides. Log of 1.07. That's not the general way I do it. The general way I do it is I actually will apply natural log or log base 10 to both sides. I'll show you that they both give the same answer though. So let me do the way I do it first, just so that we have what I'm gonna write. So I'm gonna apply natural log to both sides. If I apply natural log to both sides, then I can take the x out front because of the rule we learned last class period. So x times the natural log of 1.07 equals the natural log of 7. Now, natural log of 1.07, that's just a number. So I can divide both sides by that number. And so my value for x is going to be whatever I get when I take the natural log of 70 divided by the natural log of 1.07. That's something I can type into my calculator and get an approximate answer for. And that approximate answer is 62.79. Let me read that, 62.79. Now, the other option is to apply, all right, this one's black, is to apply log base 1.07 to both sides. Log of that base. If I apply log base 1.07 to 1.07 to the x power, I end up with x equals log of 1.07, log of 70, log base 1.07 of 70. And how would we calculate that? Well, if I needed to calculate that, I'd put this into my calculator via my change of base rule. And my change of base rule says take natural log of 70 divided by natural log of 1.07, and that's log base 1.07 of 70. So notice that we got the same exact thing, right? Whichever way, whichever approach we do it. I tend to use this approach because I don't like writing those really ugly bases. And so for solving with a different base, just apply natural log, isolate the exponential piece, apply natural log to both sides, and then that exponent can come out front. That's the technique that we're going to use a couple of different times here. So let's do some examples. Let's say we invest $2,500 into some account earning 5% interest compounded monthly. Right? How long will it take until the money grows to, let's say, $8,000? So this is a pretty typical word problem with solving exponential equations. Since we're compounding monthly, I'm going to use A equals P, 1 plus R over M to the MT. My final amount is going to be 8,000. My initial amount, my principal, is 2,500. My rate is 0.05. M is 12. And the T is the thing that I don't know. I want to know how long it's going to take until we get to 8,000. So we're going to solve this exponential equation. We're gonna divide both sides by 2,500. I got 3.2. And then at this stage, I have a base to a power on the right-hand side. It's okay that this base looks really ugly, okay? That's perfectly fine. In fact, I chose this because it was going to have a fairly ugly base. So let's just apply natural log to both sides. Using the rules of logarithms, I can pull the 12t out front. And that's going to be multiplied times the natural log of 1 plus 0.05 over 12. If I want to isolate the t, I want to solve for t, right? Then I'm going to have to divide both sides by 12 times this natural log. The 12s will cancel out, these natural logs will cancel out, and we'll just be left with a t on the right-hand side. And on the left-hand side, we go natural log of 3.2 divided by 12 times natural log 1 plus natural log 0.05 over 12. Be careful when typing that in. When I type it in, usually I take natural log of 3.2 and then divide by 12 and then hit enter. And then I divide by the natural log of 1 plus 0.05 over 12. And I got roughly 23.31 as the t. So it would take about 23.31 years to go from 2,500 to 8,000. Oh, that's weird. By the way, this is again a typical word problem. All right, typical word problems. Things of that nature. Let's do another word problem. By the way, everybody get that 23.31? Here we go. On your calculator stuff. Let's say there's a population of a city. That is 45,000 now. And it's decreasing at a rate of 1.7% continuously. How long until the city hits 30,000 people? It's a population of 30,000 people. Well, if we are compounding continuously, that's my A equals P e to the RT. And again, some people, when they write this, won't use A and P, they'll use A and A sub 0 for your initial amount. A sub 0 is just another letter people use for initial amount. So we're saying how long until it hits 30,000? If it's currently 45,000. Okay. Now, here's the thing about the rate. The rate is decreasing at 1.7%. That's a negative 0.017 for the R. That's the key. Remember, decreasing is a negative R. Once I've set this up, I solve it in the exact same way I did before. I take 30,000 divided by 45,000. That's actually 2/3. I'm going to keep it at 2/3 so I don't have to round right now. Okay. I don't want to round quite yet. Is equal to E to the negative 0.017 T. Now at this point, this one's nice because we have base E. So if I have base E, I can just apply natural log to both sides. And the natural log on the right-hand side is going to cancel out with the E, and I'll just be left with the exponent. You can write a step where you just put natural log on both sides and then cancel it out if you like. I just didn't. And then at this stage, all I have to do is divide by the coefficient of T. Natural log of 2/3 divided by negative 0.017 gives me 23.85. Approximately, obviously. So that is how long it's going to take. It's going to take about 23.85 years for this city to fall to a population of 30,000. Now, let me give you another concept. All right. And this is sometimes what how people will phrase things. All right. Let's say I know, or we know, an investment doubles every 9 years. So we have some investment that's going to double every 9 years. If we put in $1,000, how long until the investment is worth let's say $30,000. So if you're given the doubling time, by the way, this would work also if you're given the time it takes to be cut in half, like a half-life. So half-life of nuclear material, they often talk about things like that. Well, doubling every 9 years. Again, you can use A sub 0 or P, it doesn't matter. If we're given a doubling time, basically, the equation you're going to use is going to be base 2. 2 for doubling. If it were half-life, the base you'd be using is a half. T still stands for time, and then this letter here, if it's doubling time, often that's used as a D for doubling time, obviously. And if it's half-life, oftentimes it's an H for half-life. But that gives you the time it takes to double. So let me explain what I mean by that. So how long is it till it's worth 30,000? That means the end amount should be 30,000. The initial amount should be 1,000. And then my exponent is going to be T divided by 9. And you can think about what's going to happen here. When T hits 9, the exponent is going to be a 1, and so we're going to multiply by 2. We follow that? Which is a double, right? So when T is 9, the exponent now is a 1, and the whole thing doubles. And then obviously we can solve this equation, but that's the key, is that doubling time, half-life, if I know the time it takes to double or the time it takes to cut in half, you can just use base 2 or base 1/2. So let's go through solving this. Divide both sides by 1,000, and you get 30,000 equals 2 to the T over 9. So 30 equals 2 to the T over 9. That 30,000 becomes 30. 1,000 cancels out. Then I'm going to apply natural log to both sides. and then bring my exponent out front. Hopefully we've done enough solving to realize that if we're dividing by 9, to undo that, I should multiply by 9. And then multiplying by natural log of 2, to undo that, I need to divide by natural log of 2. Is that okay? Here to here. Multiply by 9 on both sides, divided by natural log of 2. And I end up with 44.16. So it's going to take 44.16 years for that $1,000 to turn into $30,000. So that's if I know the time it takes to double. Then I have this special formula 2 to the t over doubling time. Any questions about solving these exponential equations? So that's basically the end of chapter 4, solving this. Now, there's one thing that I kind of skipped over, and I'm going to try to do that really quickly right now. I haven't, the most of the end of chapter 4, 4.6 and 4.7 is solving exponential equations and word problems with exponential equations. Okay. There is a little bit of solving log equations too. Let's say I have a log equation like that. If you're solving a log equation, what you want to do, when I say log equation, I mean when a variable is inside of a log. Okay? What I want to do on one side is create one log expression. So this is log base 2 of x minus log base 2 of 4. So on the left-hand side, I'm going to combine that using the rules of logarithms. Remember, if we're subtracting logarithms, then we're dividing the components on the inside. And then if I have a variable inside my log, what I'm going to do is rewrite as an exponential expression, namely x over 4 has to be 2 to the 7th power. And then this is something that I can easily solve for x. Two to the 7th is a pretty big number. 128. And then I multiply by 4 on both sides. And I get an x value of 512. Okay. So if I ever have to solve a log equation that has a variable inside of a log argument, the way to do that is to create a simplified version of log as I can, We did a lot of these last time, simplifying log expressions. And then rewrite it as an exponential. Okay. You're not gonna have a lot of those, but they do exist. All right. Now, because we had such a weird day today, and we got started so late, I'm going to push the test back to have it due date Sunday at 5. Okay? So I'll push the test back to have due date Sunday at 5. That gives you a little bit of time to study. I will be around tomorrow, but on Friday and Saturday, I will be out of town, so I probably will not have access to my email. So if you do have questions, please ask those tomorrow rather than Friday, Saturday, because I'll just be out of town. But this gives you all the tools you need. If you do have any questions on problems and how to set those up, again, please email me, check those out. All right? And then next week is our spring break. So have a good spring break and have a good test, right? See you later.